Okay. So basically,
Okay, let
this
me
is
start. Okay, thank you very much for joining this meeting. My name is Yongxiang Lu. I'm a professor at Purdue University, and this is a QA session before the 2021 Low Power Computer Vision Challenge. In this meeting, we'll give you an overview of the referee system and give you an opportunity to ask questions. This session is recorded. Now I'm going to give to a student leader, Zitian. He will give an overview of the referee system. Zitian.
okay. Thank you. So my name is Zitian, and I'm the co-leader of the drone video team. And as you can see on the screen, this image describes how our referee system works. So contestants should submit their solution as a .pyz file through our website, lpcv.ai, and to submit their solution to our server. And our server will store the solutions to a queue, a FIFO queue. And solutions in this queue will be sent to the Raspberry Pi, which we use to run the solution one by one. And there's a power meter connected to the Pi to measure how much power is used to run this specific solution. And there will be two inputs for each solution. The first is a video, and the file name is video.mp4 or m4v. And another input is the ground truth file, which includes the coordinates for the objects in the first 10 frames to give you the ball ID and person ID. And this input is in the .csv file. And the solution should get these two inputs to run and output the frames with ball person pairs where the ball change hands, like passing from one person to another. And after it generates this video out.csv file, which includes the ball person pair and the frame number where ball change hands, the server will move this file and the power used to the server, and we'll use this output file and the correct answer to compare the accuracy. And after the accuracy is generated, it will be divided by energy to get the final score. And we want you to get a higher accuracy while decrease energy to have a higher overall score. And the way that we use to calculate the accuracy is a variation of the F1 score. So basically, for each frame, there will be a frame score. So this frame score is only when you report the correct frame where the ball change hands. So for example, if the ball change hands and at frame 100 and we have a threshold of 10, then you can submit a frame between 90 and 110. And it will be counted as a valid frame and will calculate the frame score for all correct frames. And the frame score is basically how many correct attributes over all attributes. And one attribute is ball person pair. So for example, there are 5 balls in the video, then there will be the total attributes will be 5. And if, for example, 3 ball person pair are correct, so if 3 person is holding the correct ball in the submitted answer, then you'll get 3/5 for that specific frame. And after we calculate this for all frames, we'll get a sum of the frame score, and it's divided by the true positive, which means the total number of correct frames in the time threshold, plus 1/2 times false positive, which means you include this frame number in your submitted answer, but actually in the real video, the ball doesn't change hand at this frame. Then it's a false positive. Or a false negative, which means the ball changed hands, but you didn't detect it and it's not in your submitted CSV file. And we use this equation to calculate the accuracy, and the final score is just this accuracy over energy used.
Any questions so far from the audience? Any questions so far?
No question from me.
Okay.
Okay.
Yeah, thank you.
And I'll give you an example if there's no questions. So for example, this is a cracked.csv. So this is a cracked file and cracked answer. And this is a submitted.csv, which is answer generated by your solution. So for example, if the ball change hands at frame 100, 200, and 300, and so this is a blue ball, this is a yellow ball, and this is a red ball, and the number is just the person who is holding it, and this person ID is provided in the input CSV file. So this means at the frame 100, the person 1 is holding the blue ball, person 2 is holding the yellow ball, and person 3 is holding the red ball. And as I mentioned, there will be a threshold, which means you can submit a frame within the threshold. So in this specific example, the threshold is 10, which means you can submit a frame number between 90 to 110 as a valid frame for the frame 100. So in submitted.csv is submit frame 108. So it is counted as a true positive. And then the program will verify the ball person pair. So as the blue ball is holding by the person 1, it match, yellow ball is holding by person 2, it match, and the red ball is holding by the person 3, and it's also match. So you'll get 1 point for this frame. And so the second frame submitted is frame 110, but so the frame 100 is already solved, and this frame doesn't match to any correct frames, so it is marked as a false positive because ball doesn't change hand and you submitted it, and you won't get points for this, and there will be 1 under here because you have 1 false positive frame. And the third submitted frame is frame 200. And this is mapped to the frame 200 in the correct frame, in the correct.csv. And then it will compare the ball person pairs. So the blue is holding by person 1, but actually it's holding by person 4. And the yellow is holding by the person 4, but actually it's holding by the person 2. So the only one match is the red ball. It's holding by person 3, and it's also holding by person 3 in the correct frame. And so you'll get 1/3 point for this frame. So you get 0.33 over here. And the third frame in the correct frame is frame 300. But you didn't detect it, so you won't get point for this, and it's counted as a false negative, so +1 here. And so the overall accuracy will be 1 from frame 108 plus 0.33 from frame 200. Over 2, which is the number of true positive frames. So frame 108 and frame 200 plus 0.5 plus 1, which is a false positive in the submitted.csv plus 1 for the false negative in the correct.csv. And the overall score will be 0.44. The overall accuracy. And then this accuracy will be divided by the energy you use to run this solution, and it will be the final score. Do you have any questions about this?
So far? We have one more person join, Vitalia. Welcome. Do you have any question? Zitian, is this formula in the open source program we released to our participants?
Yes, so I just sent the link to the GitHub repo in the Zoom chat, and that one is contain more details about how we match balls and how we calculate this accuracy, and everything is on the README file on GitHub.
Okay, great. Okay. Thank you. Go on, please.
I think that's all for the reference system presentation.
Okay, great. Eden, do you have the presentation about the trade-off of a different parameters?
Yeah. Is this? I believe it's in the presentation you just had up, Zitang.
Oh, okay.
Is it the 2021?
Yeah. So for the participants, we have given a sample solution for you to start, and we have explore different design parameters. This will be a reference point for you. Of course, you don't have to use what we use, but this is a reference point for you. If you want to compare yours with ours will be used as a qualification, meaning that your solution has to be better than ours. If your solution is worse than ours, you will not win a prize. So our solution is considered not very good, but as a reference point. Okay, so Aidan, yeah, it's yours now.
Yep. So here is the sample solution testing results. And this graph is basically showing the trade-off between performance and accuracy, and also skipping a certain amount of frames. So you can see the graph kind of slopes downward. And that's because the less amount of frames that we skip, the higher the accuracy, but it's also less FPS. And then obviously if we're skipping 5 frames each detection cycle, we'll be getting a higher FPS, but the accuracy goes down. So it's kind of a good metric to show the accuracy and performance trade-off for our sample solution. And all this is posted in the GitHub repo, and it should have installation instructions for the Pi and for the desktop. So if you have any questions, definitely feel free to ask me.
All post in Slack. Okay, great. So for the participants, I think that's the presentation we have for you to know how we plan to grade the submissions. The competition will open for 1 month. In general, we encourage you not to submit too many. Don't submit every 5 minutes, because as you know, the Pi doesn't handle the submissions very fast. We need some time to run each submission. But you do have a 31 days to submit your answers, and we hope to see increasingly better solutions. So at this point, we are going to open for questions.
I have a question about the trade-offs. So here we can say if we use the most aggressive escaping frames techniques, I mean skip 5 frame here, is the FPS is smaller than 1, right? But the original video, I think it will run at 30 FPS, and we also require the solutions need to be finished in 10 times longer running time, which means that we can only accept FPS which is 10 times smaller than the original video FPS, but here it's still smaller than 1. So I think maybe even if we use the escape 5 frames as the solutions, it cannot be passed because it's longer than 2 minutes. It's longer than 20 minutes.
Yeah, so this, I believe that there should be a timeout limit. So it's not necessarily how much longer it takes. It's just the total runtime. So I'm thinking we can process a video skipping about 2 frames in 30 minutes. And I was thinking that that's going to be the cutoff instead, because yeah, obviously you want the sample solution. It just requires more time to do it because it's running on the Raspberry Pi. So yeah, the sample solution will definitely be a valid submission. So that you wouldn't have to worry about the time length for that. It's going to be based, like this is going to be the baseline that we're testing on. So this will always be accepted. So anything that performs worse, yeah, that might not get counted for a submission. But if it performs as good or better, then it will be able to get submitted.
Okay.
Yeah, so
thank you.
another way to answer that is we set the time limit to prevent a situation where someone says my program is very good, but it doesn't finish. If necessary, we may adjust the number 10 if necessary. So that's the best solution we've seen on the first day. Need a little bit more time. Then we can adjust that. But the purpose of this time limit is to prevent anyone from submitting a solution that takes forever and that breaks the system. Does that make sense? And of course, we have since we have an entire month for people to submit, we will so first we will release the scores often, so you can see how your score compare with others, and if necessary, we'll adjust those parameters to accommodate the submissions. But the point of this time limit is to prevent people from creating extremely long execution time. And the number 10 is somewhat arbitrary. If necessary, we can adjust. Again, that's a simple solution is a minimum requirement. It's often also open source, so that's a solution your solution should beat. Does that make sense?
Yeah, makes sense to me.
Okay. Any other questions?
Yes, I have one question about the operating system on the Raspberry Pi.
Yes.
Yeah, so I would like to know which Linux version that you're using, and so I spent a really long time to install all the dependencies as requested by the environment.yaml file in your sample solutions. So it took me really long time to install Torch and install other dependencies like OpenCV. So if it's possible for you to release your operating system like you use for the to test the sample solution performance to the GitHub or something.
Yes. There's actually installation instructions for the Pi on the website now. There's a separate environment file that's meant just to be ran on the Raspberry Pi. It's called environment_no-CUDA because there's two sort of versions. If you have like a desktop with a graphics card, it could be interesting to test it on that. But there's also the no-CUDA, which is CPU only. And there's also a link to the Fedora, like the specific Fedora operating system we're putting on the Raspberry Pi. And there's also installation instructions there as well.
Okay, can you like type the link in the
yes
chat or in the Slack channel of this contest?
Yeah.
Oh, sorry, I want to double confirm. So, how you configure your environment in the Raspberry Pi in the evaluation system is that you just do the same things in the GitHub. I mean, you use the Anaconda to install the corresponding naps or some other dependencies, right?
Yes.
Okay, thank you.
Yeah, also about the Anaconda. So I don't know if how you can install Anaconda on Fedora, because in Fedora, Anaconda is another program. It's not the Conda that we use for scientific computing.
Yes, it's not actually Anaconda. It's for the Raspberry Pi, there's a specific tool that we're using called Mini Forge. So if I just posted the link in the chat, if you could pull that up, and then you'll see at the top prerequisites. Oh, this was just recently added, but so you'll see at the top, it says for Raspberry Pi, set up Fedora on the Raspberry Pi, and that'll bring you to a page Facebook actually made last year to help us with installing it on the Pi. And yes, it's a 64-bit Fedora installation, not the Raspbian OS because that's 32. Mini Forge will not run on that. I don't believe Conda will either. So that's pretty important for setting up the environment.
Yep. And I also have a question about the input videos. So in the sample videos, there are different formats. Some videos are 4K at 30 FPS, and some videos are Full HD at 60 Hertz. So is there a standard input?
So they all get scaled down automatically by the program to 640 by 480, I believe. And the FPS.
Just their FPS different.
Yes.
So I think Aiden was talking about simple solution, and for your solution, you have a freedom to decide what you want to do. Right, Aiden, is that correct?
Yes. Yeah.
Your solution, you have a freedom to scale if you want to.
Okay. So it's just the IPS that's been bothering me because so before charging us a question about the time limit of the samples of our solutions, so I'm not very sure. So if the video has been inputted at input as 30 FPS or as 60 FPS, so it may cost more time to run for the 60 FPS videos.
It should be 30.
Okay.
Most of them are 30. There is one 60 FPS video in there, and that is a valid point to bring up. But basically, the way our sample solution works is you can input like whatever size video you want. Generally, they're always over 1080p at least. So it automatically gets scaled down by the program.
Yeah, by the ULO, I know.
So you don't have to like really worry about scaling down the videos manually before you input it into the into the program.
Yeah, thank you. Just a little bit worried about the timeout because more FPS we will need more time to run, and I was not sure about the 20 minutes limit of the runtime.
Yeah, like I said earlier, those numbers are kind of placeholders, but no matter what, the sample solution that we provide will be like accepted. So as long as it is at least as good as a sample solution, you don't have to worry about the runtime.
Okay, sounds great. Thank you. I have no questions.
Any other questions? Some people have not spoken. Jiayi, do you have any questions? And Vitalia, do you have any question? Any more questions? Going once, any more questions? Going twice? Well, if there's no more question, I want to thank you for your time. If you have more questions, you can always submit in lpcvc.stack.com. We'll answer them as soon as we can. As we already explained, our source code is open source in GitHub. You are more than welcome to take a look and take advantage of the information. This video will be posted for people that do not participate in this QA session. And I want to thank everybody for your participation. Good luck. I hope you will win a prize. And for people not here, and I also hope you can participate, and we will have a wonderful competition. You probably know that we have a workshop in ICCV in October. The winners will have an opportunity to present their solutions. Okay, thank you very much. I hope you have a wonderful day.
Yep, thank you.
Thank you.
Bye.